and welcome to our lecture for Chapter 1, The Roles of Data and Predictive Analytics in Business. In this chapter, we have several learning objectives. First, we are going to learn how to explain predictive analytics and how we can use these analytics to form business strategies. Then we're going to distinguish between structured and unstructured data. We're going to differentiate units of observations. We are going to outline a whole data generating process. We're going to describe the ways that data analysis is used to aid in our business performance. And then we're going to discriminate between lead and lag information and between active and passive predictions. And we're going to recognize what questions would pertain to business strategy that we might use when we're using these types of predictive analytics. So let's start with a few definitions. Data. Data is just a bunch of information, and typically data can be organized in a database, which is just a collection of data that typically organizations use for analysis, which leads us to business analytics, right? We're taking a bunch of this data and we're trying to use it to make business decisions, and typically we're making business decisions based on allocation of resources, which is always probably cash. And then we want to use the data that we have to make predictive analytics, right? So we want to try to form predictions about the future and possibly forecast financial statements and just see where we can try to traject our business organization. So business strategy, basically those are plans of actions, right? This is what a business would do to achieve their objectives, right? And business objectives often include shareholder maximization, profit maximization, possibly maybe increasing employee satisfaction or morale. You would use this information to make pricing decisions on products, or maybe utilizing funds for advertising campaigns, or especially now in this type of tight labor market, possibly using methods of how you're going to structure your employee compensation to attract the very best employees. So with no data, we don't really have any strong theoretical model, right? We need to be able to have enough data to predict these business strategies. And then we need to structure our strategies around theoretical arguments, right? So we're going to take these arguments, put them with the data, try to use it as a tool to predict what the effective business strategies for this particular organization are going to be. So predictive analytics is the component that gives us these pieces that we can successfully kind of formulate our business strategy. Now let's talk about data. Structured data, one of my favorites, is when you have data that you can put into well-defined units of observation, right? You put them in a form. So here we have years of sales data, or sales revenue. Nice, structured in a nice type of a little Excel spreadsheet, my favorite. As any accountant, we do not really like unstructured data, right? You really can't put it into some type of classification or format. Here you see we have years in one, we have sales, it's all over the place, right? So we like it to put it in a format that's structured so we can hopefully use it for analytical purposes. So a unit of observation, typically in most organizations, we want that to be the very bottom type unit, right? So this is the entity for which you have information that is collected. It is typically a critical component of our structured data. It tells us the way in which the information in the data set that we have, how they vary, and it hopefully helps us answer the question of who, what, where, and when, so that we can try to formulate some information from that data. Then we also have types of groupings. There are 4 major groupings. We have cross-sectional data, and then we have pooled cross-sectional data, time series data, and panel data. Time series data is probably one of the ones that we use most common when we are trying to do forecasting of financial statements. So let's look at some cross-sectional data. Here is the data, and it just gives you a snapshot of information at a fixed point in time. So here we see the employee, and we see dates, and we see sales numbers. Then we have pooled cross-sectional data. And these are basically a combination of two or more unrelated cross-sectional data, and you're trying to merge them into one. So here you have the name of a person, their height in inches, their weight, and when this was taken in the month in which they were weighed and measured. Then our time series data. This is basically data that you have that's for variations of time. So here we see we would have from 1995 all the way to 2018 profits in millions. And this is where in a lot of the business and accounting and finance, we tend to focus on time series data. And then panel data. Similar to our cross-sectional units, but here we have multiple points of time. So here you see the number of visits for each of the search engines, Yahoo, Google, and Bing, and how many millions times in these months that these particular search engines were visited. Then we have a data generating process. So the underlying mechanism that produces the pieces of information that we have that is contained in the data set. So this This data generating process, it could be formal or informal, but the key is you want to understand the variables. That's the important part of it, because you're going to use these variables to create some type of statistical model that hopefully is representative of the population. And then you're going to collect and analyze these variables, and you're going to perform tests like descriptive statistics as a simple test to see what the data is telling you. So we have types of queries that we use, right? So data analysis and techniques, right? So we have queries, we have some type of pattern discovery, we have some type of causal inference that we might want to get from the data. So any request for information from a database is a query, right? And then we're going to use that to derive some descriptive statistics, which are just quantitative measures, and it helps you summarize the data set entirely. And we might do that through pivot tables, which helps us just to kind of drag and drop, especially in Excel, to see different views of the data. Also, Tableau is another great visualization tool that will help us to kind of see how we can put the data into a picture or a visualization. Then we have patterns, right? We want to look at to see between the data sets, between the variables or the observations, are there any relationships that we can discover, right? We want to see data mining, which is where we're trying to take a pattern discovery and we're trying to go through the data to see what it's telling us. Like we're going through the data set to see what is the story that the data is trying to tell us. And we have various types of pattern discovery. We have association analysis, cluster analysis, and an outlier detection. So association analysis, you're looking for probabilities that you're trying to determine the relationships between two or more variables. Cluster analysis, you're looking at the observations to see if they're kind of all around the same, the similarity between them. And then an outlier detection are usually like a couple or a handful of observations that they're completely different from the majority of the other observations within your population or your data set. So here are some types of pattern discovery, and you see here we have our outlier, that number 7 right here, just hanging out all by himself over there. And then here we see our association. We see pretty much all of our data points all over the place, and we might want to maybe single him out or him out as possibly our outliers. So now let's talk about causal inference. The process of establishing a causal relationship between variables representing a cause and a variable representing the effect, or the change in the cause variable resulting in the changes of the effect variable. So we have direct and indirect. So a direct causal inference is a change in the causal variable x that is directly affected by the change in y. And an indirect is we would have a change in x that may cause a change in y, but it might also have an impact in z. So we use causal inferences in two ways, with experimentation and with econometric models. And you'll see the econometric models are probably the ones that you will see quite often in scholarly journals. And then we take our causal inferences and we use them for two important applications: predictions of possibly financial statements, or campaign evaluations, like if we're evaluating a marketing or an advertising campaign. So we have lag information, right? This is information about the past, and it contains, quite often we might have KPIs, key performance indicators. And now we see several software packages like Tableau or Microsoft Power BI that gives us these great dashboards that give us these KPIs. And these are variables that we want to use to help measure our firm performance. And it really helps us answer the question, what is happening in our organization real time? And this information is usually generated, we would get them through queries, or we would try to discover any patterns, and we would see those causal inferences based on the variables that are under our study or our KPIs. So reports are often one type of lag information, right? We would do a presentation. We might also have scorecards, like our balance scorecard is more of a structured assessment of variables that would be of interest, or the KPIs that we're looking for. Dashboards, those are probably the most common now because it's more of a visualization or a graphical presentation of where we currently are and how that pertains to our historical trends, and if we're hitting those KPIs that we need to. So here's one of my favorite reports. Love monthly sales reports, right? So this is just a bar graph, and it shows you your sales of small vehicles, large trucks, and SUVs for January through August, so for the first 8 months out of the year. And this type of bar graph is really relatively easy to complete in Excel or in Tableau or in Power BI. And now here is a great example of a dashboard. So here we have our sales mix where we're looking at sales per category. And then we have our competitor sales here. So we get to see where our sales trends are for each of the three product lines, in this case, small vehicles, large trucks, and SUVs. And then we get to see where our sales are in comparison to our competitors here. And a scorecard as well. So you see the goals here. This is kind of going in line with our balance scorecard, which we have the 4 goals: financial, customer, process, and learning. And then for each goal, we have a measure and how we're going to follow up, what the target is, where we are, and the performance, if we're within an acceptable good level, or are we getting close to that acceptable level, or are we way too high? And the responsible party, which in this case, the sales manager, seems to be quite busy with financial, customer, and learning. And the inventory control manager is part of our process goal. Then we want to take this lag information and move that to lead information. And that is information that provides insights into the future. Like, we want to try to have that crystal ball and predict as to what is going to happen. And what this allows, it allows firms to do some future planning, right? We can set future expectations. We can decide on more strategic moves. And this information is presented in some type of standardized format so that we have an actionable goal. So we use this lead information to do predictive analytics, right? So that is just a type of data analytics that we're trying to take this information and make forecasts and try to create that into lead information by way of either active prediction or a passive prediction. And a passive prediction is where we're using predictive analytics and we're trying to make predictions that we're basing it on either actual or hypothetical data where no variables are exonerously altered. So that means that the variable in the data set that changes due to the factors outside of the data generating process, if they're independent of all the other variables within that data generating process. So some examples of these exonerous altered variables are weather, right? We would have customer predictions, or then we want to possibly use some data mining to see what type of patterns are discovered and how we can use this data mining and these patterns to make predictions that we would use for these passive predictions. And then we want to build a model to fit. So the basis of these analytics, we want to choose the model that would get us to this passive prediction. And then we have active prediction. And here we're using the same predictive analytics, but it could also be on actual or hypothetical data. But in this case, one or more of those variables are exonerously altered. So now we're making active predictions where we're using the relationship between X and Y. And we're seeing what the change in X happens and how that would affect Y. And we're trying to find that causal relationship between the two variables. And we're trying to predict this outcome for several different strategies, right, regarding whatever we're looking at, the application of our active prediction. So in order for us to predict an outcome, we need a range of some type of competing strategies. And then you have to establish the causal effects for those strategies in that outcome. So you want to leap from correlation to causality. That's a big one, right? And then if you do that, you could possibly have some really grossly, significantly incorrect predictions. So be careful when you're going from that correlation to causality. And that is the end of this video lecture. Hope you enjoyed it. Thank you for watching.